Hey folks, this is question 2. So part A is a proof, so you just have to learn this proof off. It's a mandatory proof in your textbook. So the way it's done is you have to use this identity. So cos of A minus B is equal to cos A cos B plus sin A sin B. So you've already kind of proved that already, so you can use this to prove this one that you have to that they're asking you to prove in the exam. So what we do next is that we replace A with 90 minus A, and it's just going to help us derive this. So we're going to get so cos of 90 minus A minus B is equal to, so it's cos of 90 minus A cos B plus sine of 90 minus A sine B. And then because we've got cos of 90 minus A, we can turn that into a sine A. So we've got sine A cos B plus, and then we can turn the sine 90 minus A into a cos A and sine B. So it's starting to look like what we want. And that's still equal to cos of 90 minus A minus B. And then what we're going to change then is the left hand side, so this part here. So I'm going to change that into 90 minus and then A plus B. And again, because we've got I'll fill this out anyway. Because we've got 90 minus A plus B, so when 90 minus, we can just call it sin again, so we can interchange sin. So that's just sin of A plus B then. And that's equal to sin A cos B plus cos A sin or sine of B. And that's what we've got then. So that's the big trick there, is the 90 minus, and you can change to sin or cos. So that's just a mandatory proof. You just have to learn that off, so that's something you need to know going into the exam, and the other proofs as well, because there'll always be one of them at least on it. Okay, using the formula and without a calculator, find the value of sin 75. So the trick here is to represent 75 as two kind of common numbers, or ones that you'd see in the log tables. So we can go for 45 and 30, because there we know that we can get sin of 45, we can get sin of 30, cos of 30, cos 45 easily. You can get them out of log tables. So I'm just going to let that be 45 plus 30, and it tells you to use the thing from the start. So we're using the identity sin A plus B equals sin A cos B plus cos A sin B. So for A, I'm putting in 45. For B, I'm putting in 30. A again is 45. And sin 30. So then you can go to the log tables. And if you go to page 13, you can find these values. So sin of 45, so you go down the side to sine and go across 45, so it's 1 over root 2. So by doing this, then you're not using the calculator, so this is what they want you to do. Cos of 30 is root 3 over 2. Then you have to do plus, so cos of 45 is 1 over root 2. And sin of 30 is a half. So we've got 2 root 2 on the bottom, and on top we just have root 3 plus, and then we've got 1 and 2 root 2 on the bottom again, so you do the same thing on the bottom, so we can just say root 3 plus 1. You could simplify it further, but you don't need to. It just says to give your answer in third form, so it's in third form. So that's B. Right, part C then. So we can change sine of 2t anyway into something else. So if you go to your log tables, it's the same thing as 2 sine t cos t. So that just removes the 2t in the brackets anyway. We just have all t's now. So move both things to one side. So sine t minus 2 sine t cos t equals 0. Factorize out the sine t. Should have these in brackets really. Right, so we get 1 minus 2 cos t is equal to 0. So then one of the things have to be 0. So either sine t is equal to 0 or 1 minus 2 cos t is equal to 0. So the first one is straightforward. The second one, move over the 1 to the other side, we get minus 2 cos t is equal to minus 1. Divide over the minus 2, we get cos t is equal to a half. So we can solve then, we can just move the sign over. So it'll give us different values of t, so we get t equals 0, but then it's 180 as well, and it's 360, so it can be up to 360. So there are all the places that t will be 0, or there are all the places that for sine t is equal to 0. The other one, so if we do inverse, we just get 60, and it can also be 300 there. So you end up getting 5 different values there, so they're all between 0 and 360, so they all satisfy the equation. So that's it for part C.